talk a little about exterior versus interior angles of a triangle. So here on the top of your notes, just in case we are not quite getting this from the other pictures or as we move more into interior versus exterior, I think it's helpful if you have some visuals here for what we're talking about. So let's just mark on these pictures up here. It gives us a name, and I'm just going to mark where you would find them in a triangle. So the interior angles, so far, that's what we've been working with. The triangle angle sum theorem states that the three interior angles of a triangle add up to 180 degrees. So that shows the interior angles right there. A triangle has three interior angles. They are on the inside of the triangle. They are in between the sides of the triangle. The sides of the triangle create them, the interior angles. Exterior angles only exist if you take a side length of a triangle and you extend it past its vertex, past the point where it meets the other side of the triangle. As soon as you do that, you have created an exterior angle. Let's mark in this picture where the exterior angles are. This one shows three of them. There's actually more than that. If you extended out this direction and took out this line, then you could have exterior angles in the other direction as well. Exterior, of course, means outside of the triangle. So those only exist if you extend out a side length. So we have interior angles in a triangle, exterior angles of a triangle. And then the other language that you need to be familiar with here is remote interior angles. Remote interior angles are, if this is my, so I'm going to show here in green, I'm just going to put a star right here to show that is an exterior angle. So remote interior angles are in relation to an exterior angle. So if this is my exterior angle, this interior angle would be adjacent to that. There's still lots of banging going on in my house. I have a little bit of nervousness over earthquakes and whatnot now. It's not that. It's people bringing in sheetrock to my basement. So this here is an exterior angle. This interior angle would be adjacent to that exterior angle. So these other two angles here that I'm going to mark with red arcs here, those would be considered the remote interior angles because they are interior, but they are not adjacent to the exterior angle. So to put this all together in another picture over here, I've got this picture labeled and I've got some angles marked on here, angle 1, angle 2, and angle 3. Those three angles, we're going to list down here that angles 1, 2, and 3 are the interior angles because they are created there inside the triangle, but they are also created by the sides of the triangle. So angles 1, 2, and 3 are the interior angles. Angle 4 is the only exterior angle shown in this picture. And what that means is that angles 1 and 2 are considered remote interior angles to angle 4. So the remote interior angles, that's vocabulary we need to be familiar with, and I'm going to use it through the rest of this paper. I'm going to say it a lot. And that is going to help us discover something about these angles. So, just kidding, come back here. That was already there, and that's okay. But I made it disappear for just a second. We'll have a chance to write it down because I want to show you right here. I want to have a chance to show you why this theorem exists before we just jump right to it and start writing it down. So in my picture right here, this is just to kind of lead us to one more theorem. And the fact of the matter is, you guys have already solved problems like this. You already have the knowledge that you need. But as mathematicians, as we always talk about in class, as mathematicians, sometimes we want a more efficient way to go about something. We want, if there's a faster way, we may as well use it. Let's figure it out and let's use that faster way. So in this picture, I see that I have angle A and angle B. Now notice again, just by way of review, they have labeled these angles with 3 letters. And that's because if they just said angle C, that would now be confusing because there are multiple angles where C is a vertex. So if they just said angle C, I wouldn't know if they meant this interior angle here or this exterior angle here. So they have to specify for me, and they do. And I'm going to color code this like we did in class with our pens and our buckets. So you can pretend you're in class for a minute, and I'm going to say grab a pen from your bucket because I kind of miss saying that to you guys. This right here says measure of angle ACB. So I'm going to trace this I'm going to use purple. You can use whatever color you want. I'm going to trace this angle A to C to B. I'm just following the order of their letters. And that tells me this question wants me to find this interior angle right here. Well, this I can use the triangle angle sum theorem for, like we worked on the last couple of days. The fact that the three angles in a triangle add up to 180 means that I can go 58 plus 74, and then I'm going to subtract that from 180, which I already did that, but you guys can work that out. So if I do 58, or I can just do 180 minus 58 minus 74. I'm taking those both away from 180. And the angle measure that I have left is 48 degrees. And I'll write this up here, and you guys can double check that if you want to. But if you add those up, you'll see 48 plus 58 plus 74 equals 180. So that's my triangle angle sum theorem. Now the other angle that they want is measure of angle BCD. So if I go from B to C to D, now I can see that that order of the letters is specifying for me this exterior angle. So the fact that those line up, and this is how we've done it the last couple of days, if those are on a straight line, a linear pair is one way you can say that. That means we know that they're supplementary and they add up to 180, so I can just go 180 minus 48, and that tells me the measure of angle BCD is 132. Now, take a second right now and just see if you can find that number 132 anywhere else. And we'll come back and look at and see if you guys can figure out where that was. Let's try this one more time. So on this picture here, again, I have a triangle with one of the side lengths extended. Here, I'm going to take this measure of angle FHG. So from F to H to G, once again, they are asking me for this third interior angle. So triangle angle sum theorem, here I go. 180 minus 103 minus 51, or I can add those up and subtract from 180. Measure of angle FHG is 26 degrees. So this interior angle here is 26 degrees, which means in order to find the measure of angle GHJ, which I can see is this exterior angle right here, GHJ. This is this large obtuse exterior angle here. Again, I can subtract from 180, do 180 minus 26. And that tells me the measure of angle GHJ is 154 degrees. Now, have you found where you can get those two numbers maybe a little faster? Maybe I don't have to find the purple one first. Maybe I can go right to the green one. Do you see how? Check out what we called these remote interior angles. Guess what 74 plus 58 is? 132. And guess what 103 plus 51 is? 154. If I'm going to take the sum of those and then I'm going to subtract from 180 and then I'm immediately going to subtract from 180 again to get that exterior angle, that means I can get a little more efficient here. I can skip this in-between step of subtracting from 180 and then subtracting from 180 again, and I can simply take the sum of the remote interior angles. All I have to do is do 103 plus 51 and I get the exterior angle. 58 plus 74 and I get the exterior angle, which leads us to a faster, more efficient way of finding exterior angles. Now, you can continue to do it this way if you want. That's great and that's fine. If you want a little bit more faster and efficient way, we're going to start using the exterior angle theorem, which says an exterior angle, if you want to find the measure of an exterior angle of a triangle, it is equal to the sum of the two remote interior angles. So all you have to do to get that exterior angle is add up those two. Now, the rest of the examples on this paper, this might be a point in class where I'd say go find partner, whoever, and give these a try. So take a minute right now, pause this video, and give the next few examples a try. See how many of them you can complete. If you can do all of them, awesome. If you can do some of them, awesome. Whenever you're done giving those a try, come back to this video and see how you did. So everybody right now, click pause, give them a try. And we're back. I hope you paused. I hope you tried them. It's more authentic this way. So I'm going to take you through these examples now and we will see how we did. So in a picture like this, problem number 1, I see that they are asking me for this exterior angle right here. Well, now that I have this handy dandy shortcut, and I'm going to say this a lot so that this theorem gets in your head and so the vocabulary gets in your head, the exterior angle is equal to the sum of the two remote interior angles. Notice 50 and 60, angle A and angle B, are non-adjacent to this exterior angle. That's what we mean by remote interior angles. I need the two that are not adjacent to the exterior one I'm looking for. All right, well, all I have to do is add those up, and my missing angle measure is 110 degrees. Likewise on this one, here's my exterior angle, here's my two remote interior angles. So guess what? The exterior angle is equal to the sum of the two remote interior angles. Add those up and you get your missing angle. And it should kind of make sense from the picture. I see an obtuse angle here. Well, I better get an obtuse angle here in my work. If I don't, then something went wrong. How are we doing with those two? Feel good about those? Thumbs up, feel good there? Okay, 3 and 4 just get a tiny bit trickier, but not much. Think through this. Oh, this time I already know the exterior angle. I know one of the remote interior angles and I'm missing the other one. Well, here I go, watch this. The exterior angle is equal to the sum of the two remote interior angles. Well, now I just have to do a little bit of inverse thinking, and I have to go minus 92, and I will now be finding, instead of the exterior angle, I will now be finding one of the remote interior angles that I was missing. And 123 minus 92 is 31 degrees. All right, one more like this. Look, I know the exterior angle. It is equal to the sum of the two remote interior angles. A little bit of inverse work here, minus 54, minus 54, and that missing remote interior angle is, I already worked this out this time, 61 degrees. As usual, if I make any mistakes, you guys let me know. All right, one last example here. How are we doing so far? Are we doing okay? Quinn, how are we doing so far? I'm good. I get it. Okay, good. She's so excited about triangles, you guys. I've been teaching her every day and she just can't wait to hear more. Okay, find the measure of each angle. Oh, I got some angles I've got to find. Well, I'm not going to be able to find any of those until I find this unknown piece. Actually, that's not true. I could probably find this one. But we're going to see how this all connects together and how we can do this. So the very first thing I'm going to do is find x, connecting this to algebra. Guess what? I have an exterior angle and I have the two remote interior angles. Okay, I don't have the actual angles, but I do have expressions representing those angles. So the exterior angle is equal to the sum of the two remote interior angles. Here they are, just in case you didn't catch that. The exterior angle is equal, well, that was really good. Undo, let's try that again. The exterior angle is equal to the sum of the two remote interior angles. That's where all that came from. I'm going to use that to find x. Here we go. I have two x values on the same side, so I am going to combine them. 18x plus 15x is 33x. Now I'm going to solve for x, doing a two-step equation. Minus 3 from both sides. This is 132 equals 33x. I'm going to divide both sides by 33. And x equals 4. That is an excellent thing to find, but that's not even what they asked me for. So let's see how I use that to find all these other missing pieces of information. Measure of angle r. Well, the expression is 18 times x. Now that I know x, I can simply go 18 times 4. And the measure of angle r is 18 times 4. I can do this in my brain. Let's see. How would I do this without a calculator? 20 times 4 would be 80 minus 2, 4, 6, 8. So 72. 72. Measure of angle r is 72 degrees. Measure of angle s. Here I go there. I'm going to do 15 times 4 plus 3. I'm plugging in my x value into the expression that represents that angle. 15 times 4 is 60, and 60 plus 3 is 63. And measure of angle, RQS, that's this one right here, R to Q to S. That is this final interior angle here. I'm going to use the fact that these two make up 180, and I'm going to do 180. This is the one I could have found even without knowing x, because I can just do 180 minus 135, and that angle measure is 45 degrees. And the very last thing I would do, just to make sure I didn't mess anything up, is add up those three angle measures. And I'll let you guys double check my work, because when you add those up, what should they add up to? Triangle angle sum theorem says they should add up to 180. So if they do, then we feel good about all our work. If they don't, we need to go back and check something. All right,